All right, so today we're going to talk about exponential growth and decay. So things to notice is that you could have a number. This is a number, and x is up in the exponent. So that'd be like 3 to a power of x. That's exponential. So the absolute value of a is called your y-intercept, and that's where we are in standard form. The y-intercept can change if you move up and down. And b is your base, and that determines if it's a growth or a decay. So it tells you down here, if b is bigger than 1, we have a growth. If b is less than 1, we have a decay. H moves at opposite that whatever we see, left and right, and k always moves our graph up and down. So we have an asymptote at y equals k, so whatever moving up and down. So in standard form, there's an asymptote at the x-axis, so an exponential growth, and standard form would go through 1, and it grows. A decay is just a reflection of that, and so it looks like that goes down. So your domain for both of these are negative infinity to infinity, because you can put any number in as an exponential. The range is going to be, as you can see, k to infinity if a is positive. So if a is bigger than, so if a is positive, I don't know what I'm writing right here, sorry. So if your a is positive, then your range will be from k to infinity, and notice I put a parenthesis there. If a is negative, it would be negative infinity to k. Again, a parenthesis. Your asymptote is always y equals your k value. So we're going to state whether these are growth or decay functions, and then we'll do the y-intercept, base, and transformations of them. So this right here, 1/3, makes this a decay. The 2, because it has the exponent on it, makes this a growth. 7 to a 1 over x. You got to think about that. It's kind of tricky. So that would make this 7 to a negative x would make it 1 over. So this is really 8 times 1/7 to a positive x. So that's a decay. 3/8 down here, you're looking at the 3/8. That's less than 1, so it is a decay. 2/3 is less than 1, decay. And then again, it's to a negative, so flip it up. So this is a growth. All right, my y-intercept in standard form would be 3, but then I have to move that up 1. So really the y-intercept ends up being at 4. So this y-intercept is at 1. I guess we could write this as 0, 3 to write it as a point. And this is 0, 1. So after the movement, your y-intercept would be 0, 4. And this starts at 8, so our y-intercept is 0, 8. And no movements. This one right here has a reflection over the x-axis. That's because it's negative right here. So reflect over your x-axis, and then your y-intercept would be -4 really, because it's flipped down. So 0, -4. Here my y-intercept is 0, 8. And then here my y-intercept was 0, 5. Oh wait, and this has a left 2 movement. So left 2. And this one would move it down 3. So really your y would start at 0, 2 in these problems. And so now we're going to go ahead and graph these and state the domain and range for them. So when I graph right here, I'm going to have the y, this is a growth because it's 3. 1/2 is my y-intercept, and there's no movement. So there's my graph. This right here is a growth because 3/2 is actually bigger than 1. So it's a growth, and that is a reflection over your x-axis. So originally, and the y-intercept is 1 because there's no number out in front. So originally my graph would have looked like this, but I need to reflect it over the x-axis. So my graph looks like that. The 1/2 here makes this a decay. The 3 is my initial y-intercept, and this tells me to go right 1. So originally my graph would have looked like this, and then I need to move it left 1. Right here, growth. This one moves it left 1. That 3 goes down 3. So we have left 1, down 3. The y-intercept was 0, 2, but it's a reflection, so you do that first. Reflects over the x-axis. So if there had been no movement, I would have made a growth like that. So let's go ahead and flip it first, because I like to flip and then move them. So we're going to move this point left 1 and down 3.